All right, making sure that you can see my screen and that you're able to see me in the screen. All right. Hello, my name is Nicole Thomas. I am in Quantitative Research Methods 6356. Tonight, I am going to conduct assignment VRJ number 5 on ANOVA, which is the analysis of variance, and it is used to compare the means of 2 or more independent samples to test whether the differences between the means are statistically significant. Normally, we study samples, but we are going to study the populations that those that are represented by those samples. And I already have my step summary sheet. It should be VRJ 5. It is the 6-foot summary sheet. And the first thing that we need to do is step 0, which is take a look at our verb analysis framework. And as you can see right here, my research question is there a significant difference in the reading scores among students with low, medium, and high social economic status at McNair Middle School? And the verb that we have identified would be the difference among or differ among. It is comparative. The verb type is comparative. The independent variable that we're using is socioeconomic status, which is low, medium, and high status. The independent measurement level, it is a categorical variable and it is nominal. The dependent variable is a continuous, and it is reading score. So the alignment for the ANOVA test is satisfied because the primary verb differ among signifies a comparative design. And there are at least 3 levels indicating for the social economic status, low, medium, high, indicating that there's a comparison among the groups simultaneously. So the dependent variable is continuous, and we know that this signifies that we need a one-way ANOVA for the test. So the next steps of the null hypothesis, we're looking at the the null hypothesis. There is no significant difference in reading scores among students with low, medium, and high ACS status at McNair Middle School. So for that, it would say that mu sub 1 equals mu sub 2 equals mu sub 3. There is nothing special between the groups. Let me move this over a little bit. All right, the alternate hypothesis is that there is a significant difference in at least, according to the literature of rabbit, it had in at least 2, but according to Dr. Cooper's video, it shows that at least 1 of the sample groups at least one of the reading the groups for the reading scores among students with low, medium, and high ACS status at McNair Middle School. So this is saying that there is a significant difference with at least 1. And so here, I have mu sub 1 is not significant, or to mu sub 2, and or mu sub 1 is not to mu sub 3. And or mu sub 2 is not equal to mu sub 3. These are, this is according to Rabbit, and I did cite it here on our summary sheet. All right, we're using the alpha, we're using the the alpha of 0.05 or 5%, because this is a threshold in educational research. The ANOVA hypothesis is always two-tailed and non-directional, is all positive, positively skewed. And I believe that we can move on to steps 3 for the assumptions. And we want to take a look at normality within each group. All right, normality within each group, homogeneity of variance, and it is not robust to violation, whereas the normality within each group is. We look at random sampling, and we know that this is met because I've looked at the study set. 3 or more independent variables, and they contain completely different students, and this was also checked in the set. So all of these met. For the normality, we're going to get ready to go to the actual SPS platform, and we're going to run these specific parameters. And if we're going to look at the Shapiro-Wilk, and this is the result before, so I don't want to look at that right now. We want to just go through and make sure and stop sharing to make sure that you are able to see my screen. So that you can see my screen. I want to go back. And let's go to the assignments. Make sure I always get nervous. All right, as I was saying, I was getting nervous that you're not able to see what I see. All right, so already we're at the data window editor. I've already taken a look at the data. I have my string variables already reloaded, and the variables when we look at what I'm taking a look at, which is the social economic status. And we click here, we can see the values assigned to each one, or low for 1, medium 2, high 3, okay? And I've already made sure that the labels matched up. And so now let's go ahead and I'm gonna go and analyze, make sure that I am in the correct steps. Functions. All right, so this. Let's go to analyze. We're gonna go to descriptives, and we're gonna go to explore. All right. Want to make sure my dependent variable because it's already here. I've already been working with this. My factor, which is my independent variable, is SES status. All right, I'm going to take a look at plots. We're going to factor the levels together. Normality of plots. We do not want under descriptive the stem and leaf plots, but we do want the histogram. That looks good. All right, and the options. I want to exclude those. All right, let's take a look at the data. It is loading for us. All right, so as we take a look at the data, which is the valid side, we do have a few cases missing here, but for the valid side, we have the reading score against the low socioeconomic status. The number of students. We have 197 for low, 239 for medium, 161 for high. I'm not mistaken that all of those together equals about 597 students that we're looking at. If the reading score is changes according to how students are labeled, we should say, or what their socioeconomic status is. So we come to low, we see the mean at about 88%. All right. Um, the Cioci is at about 0.93%. All right. The mean for median is about 92. This is 92%. And for high, we have also about 92%. So it looks like medium and high, we don't have that big of a difference or range between a difference between the means of the medium and the high. So let's take a look at the Shapiro-Wilk. And the Shapiro-Wilk for low. They're all they're less than 0.05. Degrees of freedom is here. So let's look at the plots. Okay, let's look at the histogram. All right, so we see low, it's going out to the left. Standard deviation. All right, for medium, it's about the same. We have going off. Let's look at. Let's look at the high. Mean at 92%, about 91.91, which is about 92%. We round standard deviation, 8 points above or below that. And the number of students there is 161. So now let's look at the QQ plots. We don't have, they're all kind of crowded along the line, just a few outliers here from medium. So for low, so where did it all go for the high on our box plots? And so before we specifically look or before we interpret and make a decision, I want us to look at the Levines. This one are Levines. Pause because I need to make sure that you can see my screen. All right. So we would normally want to reject the null because it is showing us that the Shapiro-Wilk for the p-value Shapiro-Wilk is less than 0.05, which is less than our risk of error. And so we will reject the null. But before we give a decision, we want to look at our Levines. All right, in order to run that, we're going to come back up to analyze. We want to compare the means. We want to do one sample, one way ANOVA test. And again, my values, my factors, dependent lists are already here. So under the dependent, we have the reading scores, because that's what's being changed according to our factors, our ACS statuses. All right, so to post hoc, I already have the Bonferroni, two key. I want to specify that we are using 0.05. That is there. To continue, and I should also say that for these post hoc tests, because they're going to tell us whether or not we know that there is a difference, but we're going to a significant difference. We want to know specifically where the difference is amongst the groups, where it's significantly different amongst the groups. And so when Bonferroni and Tukey, when they align, when they are the same, we have a stronger, powerful analysis. So let's go ahead and continue with that. I want to make sure we see options. All right, I want to look at the homogeneity of variance. Fixed and random. I can only be descriptive. We don't need to do the Welsh. I do have the means plot. 95% confidence level. All right. So the tables are loading. Okay. Did anything else? Still some analysis. Looks like we have the same thing still. All right. Troubleshooting, trial and error. Make sure that we've done what we need to do. There's the main effect size. We want to make sure we do that by following the 2T. It already pulls up. I believe it has already pulled that. One moment. I'm still on see okay. It is. It is pulled up. All right. So here are tests of homogeneity of variances. Let's see, we have equal variances amongst the groups. And so we also have the ANOVA table and the effect sizes that calculates our eta squared, which tells us how significant that variance is. And so when we look at our degrees of freedom, we have two. That means that we had three groups minus one, and that gave us the two. And here is our significance based on the mean. Our living statistic is 0.180, and that is greater than 0.05. Let's look at the ANOVA table. Between the groups, we had degrees of freedom. Okay, it's still the same. And as I told you, there it is right there. Within the groups, 594 degrees of freedom. Between the groups were two. That's the amounts minus one. And then when we subtract that from the number, what was it, 597, we got 594. I'm a little bit off, it says 596 is the total, okay? The F value, which is 11.89, when we have an F ratio that is statistically significant, and it is correct. If it's less than 0.05, then we want to reject the null. Mhm. All right, our eta squared right here is at about 4%, and it's telling us that it's kind of small though, that there's a 4% variance between the groups of low, medium, and high, whether or not they impact the reading scores. So there's no significant difference. All right, let's look at our post hoc test that tells us it's specifically where. So on high, we get 2 gigs, significantly about 98% right here. Well, I'm sorry, 9%. Same. So let's look at the confidence level. Let's see. Zeros, well, right here, we include 0 in the medium. That's a violation. Same for high. It says the mean difference is significant at 0.05. Now there's something that's happening, but it does not appear to. Now there's a difference. That's what the p value is telling us. So let's look at the means plot. Look at the reading scores for the lower economic, socioeconomic students. The mean reading scores are lower for students at the low economic status. Right here between medium and high, there's a difference, but not a significant difference. And in saying that, that number at 0.39 eta square, it shows us that because there's a 4% variant in between. But P is less than 0.05, we will reject the null. That will be my decision to reject the null. So that there is a significant difference between low, medium, and high socioeconomic status among the reading students, reading schools of students at McNair Middle School. Hold on 1 second. It appears that we've been paused. All right, I'm not for certain how my screen keeps stop sharing, but I want to go back through and show that was a one-way ANOVA was conducted to examine the effect of socioeconomic status on reading scores. There was a statistically significant difference in the reading scores among the three SES groups that were low, medium, and high. We have our F statistic or our F ratio, which is at 2, and that was the number of cases minus 1. And then 594, these were the cases, both the cases within and between, and it equals about 11.89, just about 12. P was less than 0.001. That means it's less than 0.05. So we reject the null. N superscript 2 is at 0.039, which is about a 4% variance between the three groups. Post hoc comparisons used the Tukey HSD test, and it indicated that the low SES student group scored significantly lower than both the medium and high SES groups, while there were no significant difference found between the medium and high SES group, which was that 4% variance. We want to also, let me pause and go back. Let me make sure that you can see my screen. Okay. Pause and go to, it says that it has stopped sharing once again. All right, so we want to take a look at our G power, and this essentially tells us that gives us our power to know what our sample size should look like. So we want to change this from F test, T test to F test. Oh, not at an ANCOVA, but we're at an ANOVA. All right. Fixed effects omnibus one way. All right. And so our effect size was 0.39. This is at 80% power. We had how many groups? We had 3 groups. And I think this is correct. Oh, and I had a priority, we were at post. Okay, our sample size was 597. If it'll calculate for us. And so let's look at our beta, which is that type 2 error, which is our error. And it looks like degrees of freedom 2. What's that? Okay. Looks like we had enough for a decent sample because we had 597 student. I mean, yeah, we looked at 500. Actually, it was 596. I'm glad that I have that here. Make sure that you're able to hear and see me. Okay. All right. And so if we wanted to take a look at this before, so that we will have power before we begin the test, we will look at, it would be a priori, and this would change to fixed effects, a priori. And I know that priori means a priori is planned. And so number was what? 556 degrees of freedom. 3 degrees of freedom. So that was one number. So let's calculate and see. Oh, so it's saying that we should have had at least 2,258 students in this sample in this study. in order to give us actual power at 95%. Well, let's see at 80%. What it would say. Let's calculate. Oh, 1719, so about 1,719 students in order to give us the power that we needed to uh, for more significant findings in our test sample. All right, well, that's it for tonight. I hope that I've explained the ANOVA testing to the best of my ability. I did have some difficulties, as always, with the screen stopping, but I did my best. I hope that I was able to explain this for you. Good night.